All right, so what we're doing is stretching and compressing functions, specifically an absolute value function here. Now, what you're going to have is the opportunity to play with these. The idea is you're supposed to grab these dots, and as you grab them, it moves the function. If you grab the green dot, it moves the whole thing up, down, left, right for translations. Now, we're not translating on this problem. We're just multiplying by 1/4. So what we need to understand is that this graph is a y value as defined by the absolute value of x. So this is the parent absolute value graph, and it's right in here for the graph, the function up top. So notice that now instead of just having the absolute value of x, which is this v, we're supposed to take that and multiply it by 1/4. Well, multiplying it by 1/4 causes this graph to compress vertically. All the y heights on this axis, the points that are plotted, need to compress to be 1/4 as tall as they currently are. So right now this 4 stands here on this x vertical line. It is now 4. I need it to be compressed down on that same x line, not moving left and right, same x line. I need it to go down 1/4 of its size. Well, the cool thing is I know that 4 can be divided by 4. So 1/4 of 4 is 1. So what happens is I need that grid dot right there to go down to a new height of 1. When I drag that dot down, it will move down along with all these other ones. So I'm going to click and drag this down vertically on that same X line. I don't slide it left and right because then you get messed up. I need to go down on this same X line and stop right there at 1, and I actually need to hit the grid line right there. And then this new wider absolute value V is 1/4 as tall as the original graph. And that's the idea, is that this dotted line still represents this absolute value of x, and then now this new line that I drug it down here is 1/4 as tall. That's called a function compression, and we can stretch functions also by a similar process. So now what we're looking at is a stretch opportunity where this 2 is multiplying by the parent cube root of x graph. So this function that's currently drawn is y equals the cube root of x. That's the parent cube root of x graph, the standard basic one that we would have. Our job is to take these current y heights the way that they are. There's a height of 2 right there. There's a height of 1 right here. And we are to multiply each y height by the value of 2. And so what is currently at 2 is basically going to get drug up to be twice as tall. Well, 2 times 2 should be 4. So I'm going to take this height that is currently at 2, and it needs to go up to be at 4. This needs to go up there. And when I grab this and drag it up, it's going to drag this one up to be twice as tall. It's going to drag this one down to be twice as low, and this one down to be twice as low. So watch how this interplays. I can grab any of these and do it, but I'll grab this one and go up to 1. You see them all move at once. If I drag it just on the vertical line, notice I'm not sliding off to the right. I need to stay on this vertical line or on this vertical line where the dot is, and then it will slide the function in perspective, just a vertical stretch. It's like grabbing the y-axis and dragging it top and bottom. And I'm just going up that line. So twice as tall goes like that. I could have also grabbed this dot over here on the negative sign, which is here at -2, and just drag it straight down. But it's got to stay on its vertical x line. And so then I drag it down twice as low. It was at -2. Now it's at -4. And that is a vertical stretch, a multiplication of these y heights by 2. It's twice as tall is now what graph is showing here. So now we're going to take a quadratic function and compress it by 1/3. So this is currently what we're looking at is the parent function x to the second power. It's a quadratic, the basic, most quadratic function we can look at. And what we're going to do is take all these current y heights. This one's at 9, this one's at 4, this one's at 1, and all of them need to be 1/3 as tall as they currently are. So it's essentially, if you had a height that was this tall and broke it up into 3 equal spaces, something that was up this tall needs to go down and lose 2/3 of its height. It needs to be going down to be 1/3 as tall as the whole line. If this is a whole line, then this would be 1/3 of the way. That's what each of these in ratio need to do. They need to go down 1/3 as tall as they were. So easiest way to think that through is find something divisible by 3, like 9. That's it. Because 6 would have been, but that's going to be hard to hang on to, and then we don't have a blue dot. So 9 is divisible by 3. That's the one you want to draw your eyes to and think to yourself, what's 9 divided by 3? And that's 9 times 1/3 is the same way to think that through. Either way, you come up with 3. So our job is to take the dot right here and drag it straight on its vertical line, straight down, not sliding left and right, straight down on that vertical line, down to 3. And now that dot is 1/3 as tall as it was. What that does is it vertically compresses. It's like a big weight coming along vertically and just pressing down on this to make it become 1/3 as tall as it was, just like I was pointing down over here on the right. So now it has squished it, vertically compressed by 1/3. All right, now we're going to do the same thing with an exponential graph. And this is one of the most confusing for people because we got the 2 and the 1/8, and we're not sure what's what. First of all, let me make a note to the green dot here. The green dot moves this up, down, left, right, wherever you want it to go. And so if I grabbed it, it would just move the function. That's not the prerogative this time. The functions can shift over and up, but not this one. This one is just a vertical compression. So just playing with the blue dots here. So let's talk about the parent. The parent function, there's lots of parent exponential functions. Every one is dependent on the base. In this case, we have a base of 2 to the x power. And how I know that is looking at this function. It's the thing that's being raised to the x power. This is the parent, 2 to the x. And if I make a little t-table off to the side, the x input of 0 would put out 1 if you raised it 2 to that power. And if you did 1, it'd be 2 to the first power, which is 2. If you plugged in a 2, it'd be 2 to the second power, which is 4. And so these dots are correlating with that. This right here is 8 because it's 2 to the third power, which is the line that this one's on. That's 2 to the third. The input was 3 right here in the exponent. So again, that's why it's the base 2 to the x. Now, what's supposed to happen with those is I need to make them be 1/8 as tall as they currently are. To make them 1/8 as tall, you need to times them by 1/8. And multiplying by a 1/8 fraction is the same thing as dividing by 8, which is how my brain actually translates it. Well, 2 to the third is 8, so this is really 8 divided by 8, which is conveniently 1. None of the other ones are that nice. I mean, you could work with the 4, the height of 4, but 4 divided by 8 is 1/2, and that's not going to plot well for me. I want a nice grid dot. So find something that divides nicely as you're working on these problems. But again, the deal is they are currently at a y height set on this x vertical line. So what I do is I drag it just on its vertical line straight down to my newly found height that is 1/8 as tall as it originally was. It was 8, now it is 1/8 as tall, which is a height of 1. So it vertically compresses. Again, it's like a big horizontal weight pushing down on this graph to press it down to be 1/8 as tall. If you were being squished to be 1/8 of your size, this is what you would look like if you're an exponential graph. So let me clear the screen. So again, you can visualize this is 1/8 as tall as this graph was. So now we're going to go the other way and take the exponential graph and we're going to multiply it. So just like last time, this is still 2 to the x power is our parent, y equals 2 to the x. And what we're going to do with that is multiply it by 4. And so if we take this, understand that these blue dots represent graphs or outputs that are y heights. We're going to take them and multiply them to be 4 times as big by 4. So I need to take these dots, whatever their current y height is, this one's 2, or this one's 4, and I need to times that 4 times as big. So we got to be careful here because I can't grab 8 and times it by 4 and go way up high because I'm off the grid at 10. The same thing with 4. If I times that by 4, I'm up to 16. That's too high. So I got to be selective and pick the function, the coordinate that can be simply multiplied by 4, which is going to be this 2 right here. So if I take the 2 and times it by 4, that y height by 4, that's going to produce an 8, a new 8. So basically this is saying these guys right here are the heights that are currently the blue dots, and then I want them to be multiplied by 4. So these will become 4 times as big. So 2 4 times as big is 2 times 4 is 8. That is the new height that dot was. Notice again, I drug it straight on this vertical line, up on that vertical line on that x value of 1 on its grid line.